getting into a new-ish unit. Data and statistics is a very small part of this unit. So we've got a couple of days, scatterplots and trend lines, and a lot of vocab, and this is actually the one section where it's not a one-size-fits-all answer, right? In math, we have a lot of, like, definite answers, right? It's either right or it's wrong. We're going to start talking about things where our answers might differ between us, okay, based on the scatterplot. Because you're talking about trends, right? You're talking about trends and data. So when I look at all of these graphs that you guys have up in front of you as well, you need to analyze first and foremost, what is the trend of the data? Is it a positive correlation? Is it a negative correlation? Or is there no correlation? So as we go through looking at A, what makes you say that it's no correlation?
There's no pattern.
There's not a pattern. They're all scattered all over the place. There's nothing that says, so this is distance traveled and number of times tardy, right? Does it make sense that there would be no correlation between those?
Yes.
Your distance traveled has nothing to do with how many times you were tardy in class. Okay, so no correlation. I'm just going to put NC. What about B?
Yes, there is something.
What kind of trend?
Positive.
Positive correlation. As, this is kind of sad, as there are more pitches thrown, the number of baseballs that are used increase. That doesn't sting at all. All right. C. Positive, negative, none. C? Positive. Right? Are we looking at the same graph? Positive. Points scored on a math quiz. Points scored on a history quiz. It doesn't. So the reason we're going to talk more about the graphs in depth, but I think the idea behind this is that if you're a good student, then you're probably good across the board. You might be. There's outliers, right? If you're really good at math, this is me. If you're really good at math, you might not be really good at history. I'm down here.
I'm good enough.
Right? But for the most part, if you know how to study for tests, right? Like if you're good at studying for history, you're probably good at studying for math. Like you're just, you know.
Yeah.
D. Positive. The higher the temperature, the more people at the beach. There's probably not that many people at the beach today. Huh? E. Okay, there is a correlation, but we won't define it as positive or negative. It's actually positive, but it goes down, but then it bounces back up. It's a positive parabola, but we won't get into all that. So we'll just say that there is a correlation, but we won't define it as positive or negative. Neutral, yeah. There's some sort of pattern, but it's not positive or negative. All right, F. Negative correlation. The more you're absent, the lower your scores get. Okay, so now let's really break these down. So we're going to look at, there's vocabulary words kind of stuck out to the side on your paper, right? So every kind of question that we take care of has a vocab word that goes along with it. So we're using card F, the absences and the exam score, for our first question. So use the data graph on card F to answer the following question. Mrs. Collins made a scatter plot to show the relationship between the number of absences a student in her class has had and the student's final exam score. Based on the trend shown in the graph, approximately what score should a student with 6 absences expect to receive on a final exam? Okay, any ideas of how that would work? how would I even?
77.
Where are you getting 77?
You would
78.
75, like you would look where it's 6, 7.
Okay. What kind of trend did we decide was on this graph?
Negative.
It's a negative trend. So if I kind of outline where the trend is, somewhere in there would be the scores, right? I've kind of made a big line over all of the different scores. 6 is it in your graph or outside? Inside. 6 would be right here. So somewhere between here and here we would expect it to lie. So if we just jump right in the middle, about 75 to 80, right? Okay, now here's where I said there's not a definite answer. If somebody would have told me 70, that's appropriate, right? Based on the trend, would 70 be appropriate?
Yeah.
Okay, based on the trend, would 100 be appropriate?
No.
No. Okay, good. So about 75 to 80. And it's called interpolation because you are making a judgment within the graph. You are making a judgment or a justification within the graph. Interpolation. You're taking the graph and inside making a judgment. So far, so good? Moving right along. Okay, cross out the word causation on yours, because it's not causation. Use the data graph on card C, so the math quiz versus the history quiz, all right? Record your reflections below. A teacher collected data on 20 students for 2 different quizzes. The graph shows the relationship between the number of points scored on the math quiz and the number of points scored on the history quiz. Judy makes the following statement. The trends in the data show that making an A on the math quiz will likely cause the student to make an A on the history quiz. Do you agree or disagree with Judy's statement? There it is. It doesn't cause it. Is it likely? Is there a relationship there? There's obviously, based on the data, a relationship there. There is a positive correlation. We call this association, not causation. One thing can be associated with another, but that doesn't mean that one thing causes another to happen. If Judy said something other than cause, it could have been, well, will likely influence a student to make an A on a history quiz. Influence likely, but cause is not the case, right? Because if I made 100 on the math quiz, I told y'all my background with math and history, right? I threw myself off this graph. If I made 100 on the math quiz, which would likely happen, would that cause me to make 100 on the history quiz? Hard no. No. Still be down here. All right? That's association. One does not cause the other to happen. All right, moving on. Using card B, pitches thrown, baseballs used. In 14 games and the number of pitches thrown in these games, draw a trend line, line of fit that models the data, and write an equation for this line in point slope form. Okay, another scenario where we might not all have the same line, right? Because if I draw a line, it's a positive correlation, right? If I make a line through that data, it's kind of a large range. You're just trying to get the line within the most points as you can. So if I go through at least 2 points, does that look like I've got a good average of the data? Yeah. Somebody's line might be a little bit lower than mine, somebody's line might be a little bit steeper, but it shouldn't be that far off. So let's pick some points. about 290. About 290 what? 140? Okay, so 290, 140. About where is my y-intercept? 35? We are using estimates here, okay? Right now, we are just using estimates. I will give you more information early next week on how you can get an exact line where everybody would have the same line. Okay, do I have enough information to write point slope form? Yes. Okay, first thing we need to do is find the slope. So 140 minus 35, 105, over 290 minus 0. Somebody simplify that for me. Say it again. 0.36. Good. 0.36. What kind of form do they want us to write? Point slope. So, doesn't matter which point we use. Which point do y'all want to use? The y-intercept. Okay, so y equals 0.36. Do I need to put x minus 0? Just put the x. Okay. Using your trend line, predict the number of baseballs that will be used if 275 pitches are thrown. Okay. 275. You see how it says interpolation in it? What does that mean? Inside. So if 275 pitches are thrown, let's go ahead and make an estimate right now about how many baseballs should be used. Somewhere around 105, 110. Okay, but we have our trend line now. Which variable represents the pitches thrown? X. So X is 275, and we're going to plug it in. So Y minus 35 equals 0.36 times 275. It's 0.36 times 275. Did you already add in 35? So what was it? 134. Were we off of our estimate a little bit?
Yes.
Right now, that's okay. 134 is still an okay value, right? Okay. Don't hold on too tight to it, okay? Because we're making estimates. If I would have said 365 baseballs, that would have been unreasonable, right? It's reasonable to say 134. Okay. Now, how well do you feel like your trend line represents the data? Plot a point, represent your answer using the number line below. So 0, the trend line does not represent the data because the data doesn't have a linear relationship. Well, is that true? No, it's pretty linear, right? So your correlation, this is called a correlation coefficient. It ranges from 0 to 1 or 0 to negative 1, depending on your slope. But the closer it gets to 1, it means your points are closer to a line. So it's not quite a 1, right? Because that's not a perfect line. It's over here. It's like in here. So somewhere in there. It's close. Okay, 0.7, 0.75, that's all great. If you put anything below 0.5, I wouldn't take it. Okay? All right. Moving right along. Number 5. Scatterplot shown on card F shows the relationship between the number of absences a student in class has and the student's final exam score in the class. Draw a trend line and write an equation in point sloped and sloped intercept form. So I want you guys to do this one with your table group. So you're just drawing a line within the data. So every table's equation might be slightly different. But if I have a slope of -5 in one place, I'm not going to have a slope of positive 20 in another, right? Okay. So our lines should be around the same vicinity. somebody want to share their slope-intercept form equation?
Y minus 100 equals -4.17
Equals negative what?
4.17.
So it's alright. Then what? X? Just X? Oh, because you used the y. Okay, so then it would be y equals negative 4.17x plus 100. Do we have anybody that's differing like hugely from that? Or is everybody around the same vicinity?
We got negative 3.2.
Negative 3.75. Okay. Alright. So nobody's like negative 10, right? And nobody has a positive slope, right? Okay. So that works. So then, like I said, your correlation coefficient ranges from 0 to 1 if it's a positive slope, 0 to negative 1 if it's a negative slope. About how close were your points to your line? Negative 0.5, negative 0.6, somewhere within here. It wasn't too strong, but it wasn't too weak either, right? So about, okay, that's fine. On Tuesday, we are doing linear, what's it called? Regression. So you put all the points in the calculator and they give you the exact correlation coefficient. Okay. So, looking at card D now, the scatter plot on card D shows the number of visitors to a beach each day and the high temperature in degrees of Fahrenheit for that day. Draw a trend line that models the data and write an equation of point slope, form, slope, intercept, and standard. Oh boy. Okay, so we'll get started together. Everybody go with that? Okay. The little squiggly line, it jumps from 0 to 60, so that just means that there's data in between those. Okay, so let's pick a couple of easy points. I see a few. Maybe right here. So 80, 120, and then that's not 0 though. How about this one? About 70, 60, maybe 62. It's not right on there. Okay, we have enough information. We will start with point slope form. What is my slope? I went from 62 to 120, so I increased 58. Yeah, is that right? Not everybody at once. Thank you. 58. Okay, over 70 to 80, so 10. So 5.8. All right. Which point do y'all want to use for point slope?
81,
70, 62. So y minus 62 equals 5.8 times x minus 70. Y'all take a minute or two and turn those into slope, intercept, and standard, and then we'll talk about the other. All right. Using your trend line, predict the number of visitors that will visit the beach if the temperature is 120 degrees. Okay. That is extrapolation. How is that going to be different? Stop talking while I'm talking, please. Okay. It's outside. Extra. So interpolation is in, extrapolation is out. Because 120 degrees is over here. Right?
Why would you be outside?
Okay. So let's predict. 5.8 times 120 minus 344. Plug that in your calculator and tell me what you get.
Yeah, there's no way that would happen.
How many?
350.
Actually, it's worth more
I'm doing 1,000.
Are y'all with me?
Yeah.
Are y'all with me?
Yes, I can see the board.
Okay, you guys see a lot of talking while we're trying to. Okay, is it reasonable?
No.
Why?
No.
It's 120 degrees. Right? No, nobody's. There are not more people at the beach. When you get to a certain point, what's going to happen to our graph? It's going to fall back down. Okay. Good. All right. So that is our stuff for today. Wow, that's how you're going to.